Hey guys, how you doing? It's Jalajora here again, back with another video from BHM at GCSE Chem, and today we're doing section C4.6, which is called Expressing Concentrations. So it's quite a short section actually, and still I haven't been able to put the links up for C3.2 till C4.5, including my why should you pick A-level chemistry video. So I'll try and put all the links up on my website, to those videos on my website by today, if not by tomorrow, by the end of the weekend. Basically, I'll try and do it. So that will include C4.6. If I do it all by today, hopefully I can do it. Hopefully I can put the links up to all the videos from C3.2 to C4.6. Basically, after I upload this video on my website, basically you get what I mean. But yeah, so today we're doing C4.6 Expressing Concentrations, a topic which is actually, which everyone needs to know about. It's not triple science only. And the book that I'm using is this one. It's the AQA GCSE Chemistry Caboodle Revision Guide. There you go. Just show that there as well. And today is quite a short section, as I mentioned before. It's not very hard as well. It's let me just get my calculator from there. Sorry, I had to move myself to get the calculator, but there it is. So yeah, I think, is there anything else? Oh yeah, in C4.2, I was watching back my C4.2 video, which I think is known as, the topic is equations and calculations, I'm pretty sure, yeah, which was for higher tier students only. I said the relative atomic mass for calcium was 23 before, but then I corrected it saying 40. But I also put it in the comments, by the way, that the AR of calcium is 40 and not 23, because I said 23 in the video, but then later in the video I said 40 as well. So yeah, just to make that clear, that the AR of calcium is actually 40 and not 23. And that's from the periodic table. The top numbers in the periodic table, the bigger numbers for each element, by the way. We've been through that before. And as you can see, I'm in my room today again, making the video, recording the video. And yeah, so that's the thing. And if you're following the student book, it's pages 72 to 73 that you want to be having a look at for today's section. And I think without further ado, let's begin. Oh wait, before we even start, 2 days ago I actually changed, like in the profile photo on YouTube for my channel, it was just a B for BHM at GCSE Chem. If you go on my YouTube channel now, you're going to see that it's changed. I put like a photo of chemistry on there. So just to let you know, I forgot to tell you about that. I've done that since 2 days, but I still forgot to tell you about that change that I made to my channel. Basically, just put the photo there, and my my profile photo for my channel was just a chemistry one. It just says chemistry, and yeah, that's basically what it is. So you can check that out on my channel. It's going to be there instead of the B. The green B. I found it a bit boring. The B in the green background. I thought I'll change it. But yeah, let's begin. So it's pages 72 to 73 of the student book, which is the big textbook that you want to be looking at for this section. But yeah, let's begin. So C4.6 Expressing Concentrations. Yeah. So look at these 3 glasses of orange squash. So these are 3 glasses of orange squash. There you go. There's 1, there's 2, there's 3. Sorry if you can hear any noise, by the way, someone's phone. But the orange squash is getting less concentrated, going left to right. The darker color indicates more squash in the same volume of volume of its solution. So yeah, so you can see, because it's more darker, and here, this is the most concentrated, and this is a bit less concentrated, and this is very less concentrated, so it's known as dilute. So basically, the more dark it is, the darker it is, the more concentrated the solution, the orange juice or orange squash is. And the reason, the darker the color indicates more squash in the same volume of solution. So basically, if you have a darker color of orange squash, you have darker color of squash in the same volume of solution means you have a more concentrated squash, basically. So we're going to go through that in a bit more detail just now, if you didn't understand that. But concentrations of solutions can be measured as grams per decimeter cubed. So that's the unit for, we could use concentration. The unit for concentration would normally be, you could measure it here in GCSE, I think it's, in grams per dm cube, basically. And if you know the mass of a substance dissolved in a given volume of solution, you can calculate its concentration. So we know that. Yes, if you know the mass of a substance dissolved in a given volume, you can calculate the concentration. And basically, the equation that we're going to use, if you're working in dm cubed, the equation is concentration in grams per dm cubed equals mass of the solute, which is in grams, divided by volume of the solution, which is in dm cubed. Now, what is dm cubed? Well, dm cubed is a unit, so it's decimeters cubed. So that's what it is. And 1 decimeters cubed is basically 1,000 centimeters cubed. So if you're using decimeters cubed, then the concentration in grams per decimeters cubed, grams per dm cubed, is mass in grams divided by volume of solution in dm cubed. So, or decimeters cubed. But if you're working in cm cubed, you use the equation that concentration in grams per dm cubed would be the mass of solute in grams divided by the volume of the solution in cm cubed times by 1,000. So you're going to have to times it by 1,000 as well, because obviously we know that 1 dm cubed 1 dm cubed is 1,000 cm cubed. So that's the conversion that you need to know. Is that everything else that I have to say? I'm just thinking. Yeah, that is everything else I'm saying. So so if you're working in cm cubed, then you use concentration in grams per dm cubed is the mass of solute in grams divided by volume of solution in cm cubed times 1,000. So that's what you use when you're doing that, basically. And so that's basically a formula you need to know. So if you're using dm cubed, let's just recap. In decimeters cubed, dm cubed, the concentration in grams per decimeters cubed or grams per dm cubed is the mass of solute in grams divided by the volume of the solution, which is in dm cubed or decimeters cubed. If you're working in, if you're given the volume basically in cm cubed, then to work out the concentration in grams per dm cubed, what you do is you do the mass of solute in grams divided by the volume of the solution in cm cubed, and you multiply that by 1,000. So hopefully that makes sense. And here's a worked example as well. So calculating the concentration of a solution. So a solution was made dissolving 0.8 grams of sodium hydroxide in 200 centimeters cubed of water. What is the concentration in grams per decimeters cubed of the solution? So so we know that because we've been given 200 centimeters cubed, we're going to have to use the formula concentration in grams per dm cubed equals the mass in grams divided by the volume of solution in cm cubed times by 1,000. You have to remember to times by 1,000 because the volume is given in cm cubed. You need to convert that to dm cubed. So basically you do 0.8 grams because it was 0.8 grams of sodium hydroxide divided by 200. And then because that was the volume, it was 200 centimeters cubed, but remember to times by 1,000. And if you do that, then you should get 4 grams per decimeter cubed. Now, obviously, what you could do instead of having to worry about the worry about the 1,000, instead of having to learn 2 equations, that I'm telling you that 1 decimeters cubed is 1,000 centimeters cubed, which you, by the way, need to know that the conversion, that 1 decimeters cubed is 1,000 centimeters cubed. You need to know that. So if you're given anything in centimeters cubed, you can easily convert it to decimeters cubed straight away. So if it's 200 centimeters cubed, you know that's in dm cubed, that's just going to be 200 divided by 1,000, which is 0.2. And then you can just use the formula 0.8. You use the formula that concentration in grams per decimeters cubed equals mass of solute in grams divided by volume of solution in dm cubed without having to worry about 1,000 because you've already divided by 1,000 before. So it's essentially the same thing. But if you were to convert the 200 centimeters cubed to dm cubed, you'd get 0.2 dm cubed, and then you just do 0.8 grams divided by 0.2 dm cubed, which would give you 4 grams per dm cubed anyway. So you get it either way, basically. And this is just the working out there. There you go. There is the working out. And then it says 4 dm cubed. So here's actually a question. There's only one question in this section. It's quite a short section, actually, this one. So that's good. It's not going to be too long a video, which is nice, But let's move on. So 4 decimeters cubed of solution was made using 2.8 grams of potassium hydroxide. What is the concentration in grams per decimeters cubed? Well, this is an easy one because we've been given the volume in decimeters cubed anyway. So we just need to apply the, if we were given in cm cubed, we'd either use the formula that concentration in grams per dm cubed equals the mass in grams divided by the volume in cm cubed multiplied by 1000, or we could have converted to converted the volume to dm cubed and then done the formula, used the formula that concentration in gram per dm cubed in grams per decimeters cubed equals mass in grams divided by volume in decimeters cubed or dm cubed. But here is it's very simple because it's 4.0 dm cubed which is 4 dm cubed of solution was made using 2.8 grams of potassium hydroxide. What is the concentration in grams per decimeter cube? We don't need to do any conversions here because they're all in the correct units. We just need to apply the formula that the concentration in grams per decimeter cube equals the mass in grams divided by the volume, which is volume of solution, which is in decimeters cubed or dm cubed. And so doing that would be 2.8 grams divided by 4.0 decimeters cubed or 4 decimeters cubed. It says 4.0 here. So basically what you should get is that should be 0.7. I don't even have to work that out. I'm pretty sure that is 0.7 because it's going to be less than 1. So it'd be 0.7 what? Grams per decimeters cubed. Very important to write the units as well. Can't forget them. So let's see the answer there. Should be that. Yeah, 2.8 grams divided by 4 decimeters cubed or 4.0 decimeters cubed gives us 0.7 grams per decimeters cubed. So yeah, I didn't need to really show you that on paper. It's just dividing it. So that's the question there, by the way. You can see the question for yourself, but I've just gone through the question. You don't need to, really see. You can just hear it from me, but. And then the keywords, or the keyword, there's only one keyword in the section, is concentration, basically. That's the only keyword in the section. And then let's just go over the key points just to finish off. So the key points are that the concentration of solutions are measured in grams per decimeters cubed. To calculate the mass of solute in a certain volume of solution of a known concentration, we use the equation that concentration in grams per decimeters cubed equals mass of solute in grams divided by volume of solution in decimeters cubed. And remember, 1 decimeters cubed is 1,000 centimeters cubed. And so you need to remember that conversion, and you might need to convert, and then it's just using the formula that or the formulae that we've been through. There are 2 formulae here, but essentially, you can just remember, if you use the dm cubed one, always just remember, if you have something in cm cubed, just divide it by 1,000, then you can just use the dm cubed equation, really. It's not very difficult. And that's the end of the section, guys. And just to finish off as well, just going back to this orange squash example, basically the darker the orange squash here, just to make sure you've understood it, the darker the orange squash, you can see on the here we have the darkest orange squash, and then here we have the lightest one. So this would be known as a more dilute orange squash, basically, whereas this would be more concentrated because it's darker, because there's basically more of the orange juice in the given volumes of solution. Basically, when there's more solute in a given solvent, then it's known to be more concentrated, and when there's when there's less solute compared to the in a given solvent, then it's basically compared to the solvent, then it's basically known as dilute, because there's not much of that solute in the solvent. So hopefully that makes sense. So the darker color basically indicates more squash in the same volume of its solution. So hopefully that makes sense, guys. So that's the end of the video, guys. Tomorrow we're doing C4.7 titrations, which is also a triple science topic only. This was not a triple science one. This is for everyone. You need to know this. And it was quite a short video today. Obviously not very long. Still 15 minutes, and nearly approaching to 15 minutes. But I think I'll end the video here, guys. Make sure to share, like, and subscribe, and turn the notification bell on if you haven't already, so you're notified and updated when I upload new videos that you can watch. And and I'll try and put the links up to sections C3.2 to C4.5, I think it is, or C4.6. I don't know. Is this C4.5? C4.6. Yeah, sorry, C4.6. I might have said C4.5 before, but it's till C4 from C3.2 to C4.6, including the why should you pick A-level chemistry video. I'll try and put all the links to them all updated on my website. But yeah, until tomorrow, I'll see you guys, and thank you very much.